4-5, quadratic equations. So in this section, our objective is to solve quadratic equations by factoring and to solve quadratic equations by graphing. Factoring is the one that we are going to do most often, and that's what we're going to sort of use when we are going to take a quiz or a test on this chapter. Graphing is great, and it's good to know how to understand it, how to do it, and so we'll look at a little bit of how to solve quadratic equations using a graph as well. Our essential understanding is that to find the zeros of a quadratic function, y is equal to ax squared plus bx plus c, we must solve the related quadratic equation ax squared plus bx plus c is equal to 0. Which means that anytime we're going to try to solve these quadratic equations, the most important step is to make sure that it is set equal to 0. Okay? Let's look at this quick warm-up problem right here. So, as part of an engineering project, your team is drawing a highway tunnel on a coordinate system. The tunnel opening is in the shape of a parabola, as we can see on the diagram right there. Okay. You need to finish the drawing. What are the coordinates of the point C? Okay, so we can use what we know about parabolas to figure out the coordinates of this point. First of all, B is at the highest point, so we know that that is the vertex, which means that that line right down there cuts the parabola exactly in half because it is the axis of symmetry. So because of that, I know this distance right here is 6.4. And then this distance right here is another 8. So if I add those together, I know that this whole distance from here to here is going to be 14.4. Which means that because this line right here that goes down the middle is the axis of symmetry, this distance right here is also 14.4. Okay? And we can just add that to 6.4 to figure out that my x coordinate is going to be 20.8. And of course my y coordinate, this point is on the y-axis, so my y coordinate is 0. Okay? So now we have 3 interesting points on this parabola. We have these 2 points, the 2 points where the parabola crosses the x-axis, and we have this point B, the vertex. Okay? Those are going to be the 3 most important points when we are trying to figure out, when we're working with parabolas, is we have learned how to find the vertex. Now we're going to learn how to find the 2 x-intercepts, also called the zeros of the function. Okay? So whenever a graph of a function intersects the x-axis, f of x is equal to 0, a value of x for which f of x is equal to 0 is called a zero of the function. Most parabolas have 2 zeros, 2 places where the function crosses the x-axis. Sometimes there's 1, sometimes there's not any, but most of the time there are 2. In order to figure out what these zeros actually are, we're going to use something called the zero product property. Okay, so you can solve some quadratic equations in standard form by factoring the quadratic expression and then using the zero product property. What the zero product property says, that if I have 2 different variables and I multiply them together, or 2 different things, if I multiply them together and get an answer of 0, then one of these 2 things must be 0. That's the only way to get 0 when you're multiplying. Okay? Something has to be 0 to get 0 when you multiply 2 things together. Okay? So, because of this, when we factor our quadratic and we have my 2 binomial terms multiplied together, something like this, okay? A plus B, A plus C, it doesn't matter, whatever it is. When I have these 2 things equal to 0, one of these 2 terms must be 0. That's what the zero product property said. Okay, so let's see how to use it. Okay, so we're going to solve a quadratic equation by factoring. Okay, so let's factor my trinomial right there. And if I read it correctly, I can see that I want the factors of 6 that add to -5. Okay, whoops. All right, so let's do that. Let's take my factors of 6, two numbers that multiply together to give me 6, Add them up, you get minus 5. That's going to be x plus 3. X minus 3, x minus 2. And I set this equal to 0. Now, because of the zero product property, one of those two terms must be equal to 0, which means that x minus 3 has to be equal to 0, or x minus 2 has to be equal to 0, which means that x is going to be equal to 3, or x is going to have to be equal to 2. And so those are my two answers. Those are the two places where this parabola crosses the x-axis, at 3 and at 2. Okay. To solve it by graphing, first set it equal to 0. So we would have 2x squared plus 7x minus 15 is equal to 0. And then I'm going to plot it. Okay. I could try to factor this, and I can actually factor this expression, right? I see the factors of 2, 1 and 2, the factors of 15, 1 and 15, and 3 times 5 to get them to subtract to 7. Okay, so I know that these two are going to be negative, or actually that's not true. Let's just subtract to 7. So we have 2 times, oh, here we go. 2 times 5 is 10. 1 times 3 is 3. And I want a positive 7, so that has to be a negative 3. As I build my factors, I have x and 2x, because my first terms have to multiply together to give me 2x squared. And then the 1 multiplies together with the 3, which means the 3 goes over there. And the other term, the 5, goes right there, because the last two terms have to multiply together to give me negative 15. And I want my 10 to be positive and my 3 to be negative. So I could have factored this, and then I could have solved it. X is going to be equal to negative 5 if I set that equal to 0. And this one, 2x minus 3, is equal to 0. Add 3 to both sides. 2x is equal to 3. So x is equal to 3 over 2. Okay. So that wasn't solving with the graph. So we factor that one again. I could, however, have graphed this and looked at the graph. Okay. So looking at this graph, I can see a couple points. I can see that there's an x-intercept at negative 5, and there's an x-intercept at 1.5. So the same answers that I got from factoring, I can just look at the graph and tell. The graph also shows the vertex, which we could get if we wanted to, using the formula x is equal to negative b over 2a, and y is equal to f of negative b over 2a. Okay, to find the other most important point of my quadratic. Okay. So graphs are helpful, but since we don't have a graphing utility, you should be able to do it most of the problems by factoring. Sometimes, however, there are some problems that are a little bit more complicated, okay? Like this problem right here. So let's look at it. From the time Mark Twain wrote The Celebrated Jumping Frogs of Cavarious County in 1865, frog jumping competitions have been growing in popularity. The graph shows a function modeling the height of one frog's jump, where x is the distance in feet from the jump start. And here is my function. Y is equal to negative 0.029x squared plus 0.59x. Well, this problem is not so complicated because it doesn't have a constant term over here. So we can write this y is equal to negative 0.029x squared plus 0.59x. I should notice that both of these have an x in common. So y is going to be equal to x times negative 0.029x plus 0.59. Then I can set this equal to 0 to figure out the two most important points, the x-intercepts. So now I have my first term there. So set that equal to 0, so x is equal to 0. And that's what that point right there says, is that this frog is going to start jumping at 0. Okay? My other term is going to be negative 0.29x plus 0.59 is equal to 0. Oh, forgot a 0 in there. So x is going to equal to negative 0.59 divided by 0.029. Plugging that into a calculator gives me x is equal to 20.34. About. Okay. Now, let's take a look at these two questions right here, A and B. How far did the frog jump? Well, if I look at my graph, and I have a better graph of this in a second, the frog started jumping at 0, and my other intercept is the place where it landed. So the frog jumped 20.34 feet. How high did the frog jump? Well, if I want to know that, I have to know the vertex, the place where this function got the highest. So in order to help me with that, I'm going to graph the function. And we can see the graph of this function right here. Okay, so my estimate right here was pretty close because this frog landed at 20.345. Okay, and I can clearly see the vertex right up here is going to be 10.172 feet. Okay, so graphing can help us help figure this out. If I didn't have a graph, if I wanted to find the height of the frog, I would have to use the formula y is equal to negative b over 2a to find this coordinate, 3, and then plug 3 back in to get my y coordinate. Okay. Now, might have a question from time to time about reasonable domain and range. Okay, the reasonable domain for any the domain for any quadratic is all real numbers, but this frog cannot jump negative. Okay, so a reasonable domain for frog jumping is probably between 0 and something bigger than this, because we might have another frog. We could say we could come up with a reasonable number about what the furthest a frog could ever possibly jump would be. Maybe something around the lines of 30 or 40 feet or something like that. Okay, and the reasonable range is, well, something that's going to be over. Oh, sorry, reasonable range would be my y value. So we know that this frog got up to 3 feet. Okay, which means that, you know, my reasonable range would be something above that. Okay, and before I said that 3 would be what you get when you plug this in. This is my x coordinate, 10. So when we had figured out negative b over 2a to find my x coordinate, my vertex, I would have gotten 10. Plug in 10 and you would have gotten 3. Okay, but the reasonable domain then, the domain, let's say x is between 0 and 30, and my range y is between, y is between 0 and about 5. Okay, and that is 4-5 quadratic equations. If you get nothing out of this, make sure you know how to factor a quadratic, set it equal to 0, and find the two different factors like in this example.